I'm Chihoko Karen. I'm going to talk about gravity wave variations associated with stratospheric solar warming using long-term high-resolution model output. During SSW, there have been various observations. Left side showing the ground-based LiDAR observations showing the reductions of gravity waves, and right side showing the enhancement of gravity wave. Observation is made by the CHAMP GPS observations during the 2002 Southern Hemisphere SSW. These results indicate the strong longitudinal variation of gravity waves during SSW, and the gravity wave variation can be different for each cases. To study those gravity wave variations, we use the long-term high-resolution output from ECMWF era 5 from 1979 to 2020. We're going to study the variation of gravity waves and also gravity wave drag contributions compared to planetary wave contributions during SSWs. The ERA 5 is the ECMWF analysis data, and the horizontal resolution is 0.25. And the gravity wave with the horizontal wavelengths longer than about 150 kilometers and vertical wavelengths longer than 4 to 6 kilometers can be resolved. And gravity wave analysis, small scale perturbations are extracted using wavelet analysis and separated in different spectrum band, 100 to 300, 300, 600, 600 to 900, 900 to 1200 kilometers. Bands are used for this study. And these are the validations of ERA 5 gravity waves. We use the case, the 2008 minor SSWs. Left side is the ERA 5 results, and right side is a cosmic observations published by Wong and Alexander 2010. Temperature observation is top, simulation is top, and the zone of wind is the bottom, and temperature increase, and then zone of wind is decrease. Those are the minor warmings happened twice before the major warming at around this time. And the right side showing the gravity wave amplitude at 70 north. And top panel is the gravity wave horizontal wavelength is 600 to 1200 kilometers. And bottom is gravity wave amplitude including all of it. And this dot lines indicating the line that showing in cosmic observation by Wong and Alexander. And ECMWF ERA 5 captured the two peaks indicated by cosmic. And third peak we do not see. However, the majority of the variations are well simulated by the ERA 5. So we are going to use this data set for the previous from 1979 to 2020, 18 to study the changes of gravity waves. The criteria for identifying the major SSW is very straightforward. Westward wind reversal at 10 hectopascal at 60 north, and the statistics. So we see the 15 cases from November to February. There are more events after the February through March as a kind of a final warming. However, we are not including those results for this study. There are different kind of gravity variation I saw from ERA 5. Those are both a major SSW. This is a temperature, and this is the line plot, zone of wind at 10 hectopascal 60 north. Those are planetary wave. Wave number 1 amplitude is black, wave number 2 is red, and this is zone of mean, zone of wind, and temperature at 70 to 80 north at 10 hectopascal. The red line indicating the when the wind reversal happened, and this bottom line is the temperature variance from ERA 5. So for the 1987-88 case, there's a peak SSW occurred, but there is no gravity wave enhancement or clear signature of enhancement has been observed, simulated. However, for the 1984-85, we see the very clear gravity wave enhancement prior to the wind reversal. That's what we see a lot from the ECMWF, but there are some cases that we do not see anything. To better understand the variations, we composite the SSW events. We separated the measure events to the polar vortex split and displacement events. The split events is when the polar vortex split, and the displacement is polar vortex is displaced to one side. And then the left side showing the enhancement. At the top is zone wind and bottom is temperature, and bottom middle is temperature and bottom is gravity waves. And there's a strong gravity wave enhancement prior to the wind reversal, and the gravity wave are weaker after wind reversal. The split event gravity waves are larger than the displacement event. And this is the composite analysis of the changes during the elevated Stratopause case. Again, the top is zonal wind, temperature, and the gravity waves. And compared to the split and displacement event, the elevated Stratopause case, gravity waves are largest prior to the wind reversal and very weak afterwards. So the general trend of gravity wave change during the major warming is enhancement prior and the decrease afterwards. And here we are trying to study where the enhancement of gravity wave occurred. And this is the 40 kilometers and 30 kilometers and 20 kilometers. And the center is the North Pole. And this is pressure height, but it's about the 40 kilometers. And the line contours indicate the geopotential height and the red gravity wave activities. And for the displacement, gravity wave enhancement are mainly happen here. And split event has two locations, this over the Greenland area, and then this other side and then here we see the gravity wave enhancement. In this case, we see the connection from the low altitude, probably the propagation of gravity waves. Again, this is same for displacement event. For this gravity wave propagate up there. And this gravity wave enhancement here could be coming from the meridional propagation of these gravity waves, or could be generated in situ. We further separate the cases to the enhancement occurred in this area, and the other cases, the enhancement occurred this other area. And this area, you see the strong connection from low atmosphere. And also this area is showing the connection from the low atmosphere, but the latitude are from lower to the higher latitude. So indicating some of the changes from the for the meridional propagations. So this is the latitude zonal mean momentum flux and the zonal wind. Line plot is the zonal wind, and the white line indicates the zero wind lines. And you see that there is some meridional propagation of gravity wave along with the propagation from the low altitude. So in addition to the gravity wave variations, we study the gravity wave drag and the EP flux divergence. Previous studies show that the gravity wave drag was about 10 to 30% of the total drag, EP flux divergence plus the gravity wave drag. And their study, for some cases, gravity wave drag is up to 85% of the total drag. So we study the gravity wave drag from this year 5 data set. So this is the case 1987 SSW. And this is again the temperature, zonal wind, and zonal wind averaged over 60, 70 north. And right side is the temperature gradient, the difference between the temperature at 90 degree minus the temperature at 60 degree north. So the wind reversal occurred this black line when the EP flux divergence is very large, which indicating this planetary wave activities are causing the SSW. And this is again indicating the major SSW. At the same time, there's a relatively large gravity wave drag occurred. And prior to the wind reversal, there's the 3 weakening of the zonal wind, and those associated with the gravity wave drag enhancement. However, there's also the EP flux enhancement too. So gravity wave, not only the gravity wave, but some planetary wave contribution is there as well. but this result indicating that some contribution of gravity wave drag prior to the SSW to weakening the zonal winds. This is the line plot comparing the EPD and gravity wave drag. And this top panel showing the 15 to 10 days prior, and this 10 to 5 day prior, and the bottom is after the peak SSW. The prior to the peak SSW, we see the gravity wave drag about 8 meters per second per day and to 10 meters per second per day for the peak. And EP flux divergence is about 30 meters per second per day for prior, and weaker about after 5 to 15 days. So these results indicating that is about gravity wave can contribute about 20% of total drag, and gravity wave drag is larger prior to the SSWs. So conclusions, we analyzed ERA5 data from 1979 to 2018. And for the measure SSW case, a gravity wave enhancement are observed prior to the SSW, and split events and elevated stratopause events show stronger gravity wave activities compared to the displacement event. In some cases, meridional propagations could be important to understand the behavior. And our analysis suggests that the main driver of SSW are planetary waves. However, gravity waves can contribute about up to 20% of the total drag associated with SSW events for some cases prior to SSW. This is the contact information. If you have any question, you can email me. And thank you very much.